So good day everyone, and we are here to discuss derivative of a function. Now, our objective here is to define derivative as a limit of a function and determine the relationship between differentiability and continuity of a function. Now, the limit definition of the derivative is defined by f prime of x is equal to the limit of f of x plus h minus f of x over h when h approaches 0. And if this limit exists, then you have the answer to the derivative. Now, the notations for the derivative is written as y prime. Derivative of y with respect to x, it all means the same. It still means that this is the derivative of the y function. Now, we shall use the limit definition of the derivatives to find f prime of x. Now, slight tangent. Let's see here. Now, let's see here. This is actually why that equation was formed. The limit definition was formed. The derivative is used to find the area of a function down here. It's used to find the area right here. Now, synthesizing the equation as h approaches 0, the secant line slowly becomes the tangent line. Then, there we go. Voila! The difference quotient. Let's try this for a second. Let's say if y is equal to f of x is equal to x squared minus 3x plus 2. Now, we can identify that f of x is x squared minus 3x plus 2. But what is f of x plus h? It's easy. You just substitute the value of x plus h into the x values. So here we see x plus h substituted to x plus h squared. And 3 minus 3 times x plus h, plus 2, and distribute that, we have x squared plus 2xh plus h squared minus 3x minus 3h plus 2, and then we substitute this to this equation, which is this long one layer. It gets very long at times. Now, we can see that we can actually cancel out things here. First is x squared. Second will be 3x. And finally, we have 2. We can cancel these 3 out, leaving us with h squared plus 2xh minus 3h over h. And furthermore, we can simplify this further by factoring out h, leaving us with h plus 2x minus 3, and we can cancel out h. See? Leaving us with h plus 2x plus 3, and then we substitute h approaching 0, leaving us with 2x minus 3. Seems easy enough. Now, let's try it here. F of x equals 5x minus 2. Okay? F of x is equal to 5x minus 2. Forgive my bad penmanship. Equals 5x minus 2. I don't have a stylus or anything. Well, let me erase that. Sorry. Really bad handwriting. F of x equals 5x minus 2. And there we go. Better. Not the best, but better. Anyway. Now we can substitute for f of x plus h, we can substitute x plus h to 5x. So 5 times x plus h minus 2. And then we can substitute this equation. Oh, wait a minute. Let's It's ugly as heck. My handwriting isn't really good, especially in a computer when I don't have a stylus. Anyway, I digress. So 5 times x plus h minus 2, distribute 5 to x and h. You will have 5x plus 5h, 5h minus 2. So as limit approaches h equals 0, 0 minus, you should not forget the parentheses on this one, because that will determine the sign of what's the operation inside. So 5x minus 2. So let's see. Let's say you distributed the sign, so let's erase that. Erase that. Let's say you distributed the sign, so minus 5x plus 2. So over h. Immediately we can see we can cancel 5x, we can cancel 2, leaving us with 5h over h. So let me clear this one up. 5h f prime x, 5h over h, can cancel h, leaving us with 5. Now 5 is the final answer because we do not have any variable h's to substitute 0 to. So 5 is the final answer, and f prime of x is equal to 5. And we'll see later, we can verify that for ourselves when we study the rules even further. Now, let's try square root of x. This is interesting here because we actually have another way of rewriting square root of x. Square root of x. So, okay. Now, let's see. So f of x is square root of x, square root of x. So f of x plus h is equal to square root of x plus h. Oh wait, I think I have another file here. Wait, let me... Oh wait, I actually don't have another file. Okay, so I'll have to rewrite it. Anyway, I digress. So f of x plus h is square root of x plus h. So what's next? We substitute it. So square root of x plus h minus square root of x over h. What to do here? If we substitute 0, remember, I might not write it here, but always remember that there's always the limit of h approaching 0. So we cannot substitute 0 to h because it will make it undefined. So what we will do is multiply it to its conjugate. So I'll oversimplify it since I'll assume that you know how to do conjugates. So the result should be h over square root of x plus h over h, square root of x plus h plus square root of x over h, then should be 1 over square root of, then it should go to excuse me, 1 over square root of x plus h over plus square root of x. Substitute 0. Now we'll lose this. Square root of x plus square root of x is 1 over 2 square root of x. So f prime of x. Okay. So let's 0 is x. 1 over 2 square root of x. So that is the final answer, and I'll teach you an easier way to do it. Anyway, now, moving on to the rules. Derivative of a constant. If the function f of x is equal to c, where c is any constant, whether be it any number, any non-zero number, it's always gonna be f prime of x is equal to 0. Even scientific constants like and other your mathematical constants like pi, it will be always equal to 0 unless it's connected to a variable. Derivative of a power function. Now, the function is defined by f of x is equal to x raised to n, where n is in any non-zero constant and x is not 0. Then the derivative is given by n times x raised to n minus 1. So this one is very easy. If we go back here, you can say that 5x raised to 1. Then you multiply 1 to 5, then x will be raised to 1 minus 1 equals 0. Then x raised to 0 is equal to 1. So that's how we ended up with 5 if we use power method. But how about square root of x? Interesting. So let's go back here again. I only have 38 seconds. I think you can actually rewrite that into x raised to 1/2. So knowing that, we can multiply 1/2 x raised to negative 1/2. But how will we do this? So you can rewrite 1 over x's as x raised to negative 1. Pretty easy. So knowing that, we can now rewrite that as 1 over 2 square root of x. See? Pretty easy. And I just lost my free count. Anyway, I digress. Derivative of a constant multiplied to a function is pretty easy. You can, if there's a constant attached to a differentiable variable, you can set aside the constant, or you can keep it on, but don't forget to multiply the exponent when you do the power method. Say 4x squared. Wait, do I get to? Anyway, just imagine. I'll make do with paint. Don't judge me. I don't have any whiteboards. Or wait, maybe I do. Wait a second. Okay, I'll do open board. Okay, now we're back. Anyway, say f of x is 4x squared. My handwriting is so bad. 4x squared. So you can set 4 aside. 4 times x squared, then essentially do the power method by 4 times 2 x raised to 2 minus 1. Easy. Then you'll have 2x times 4. Then f prime of x will be 8x. Pretty simple, yeah? Now moving on. Derivative of sum and difference of a function. If a function is defined by h of x is equal to f of x plus g of x, then the derivative is given by h prime of x is equal to f prime of x plus g prime of x. What this basically means is, in a nutshell, is try to derive or differentiate every term by itself. So you can take account of the sign. Because if you don't take account of the sign, well, you'll basically get the other signs of the other derivatives wrong. Because signs is still important here, as you can get negative exponents. Now, let's try something. Let's differentiate. Let's try this one, number 4. Negative 7 over y raised to 4. We should do the trick. Okay. Y raised to this ugly handwriting. Anyway, b of y equal to negative 7 over y raised to 4. As I said earlier, we can rewrite y raised to 4. Alright, so y raised to 4, and we can take out 7. But, okay, let's try not taking out 7. So, negative 7, y raised to negative 4. So, that's b prime of y. b prime of y. Okay, so negative 4, if we apply power rule, negative 4 times negative 7 is positive 28. And negative 4 minus 1 is actually y raised to negative 5. So we can still rewrite this. We can simplify this further by 28 over y raised to 5. And that will be the final answer. Pretty easy. Decently. So let's try this. Y is equal, number 5. Y is equal to 3 pi square plus square root of x. Wow. Anyway, let me erase this. Y is equal to 3 pi square plus square root of x. So, if you remember one of the rules earlier, you could say that this is just 0. This whole, okay, wait. That whole term, this whole 3 pi square can be equal to 0. So we can just cancel that. Because pi is a constant, remember that. 3 is constant, pi is a constant, pi squared is a constant. So that is 0. So you should only derive the square root of x. And as we mentioned earlier, as we solved earlier, you can rewrite that as x raised to 1/2. So equal to 1/2 x raised to negative 1/2. Simplifying further would be 1 over 2 square root of x. Pretty easy. So final example would be, let's try this. Number 6. Negative 3x raised to 4 plus 4 over cube root of x. Let me erase this for a moment. Yada yada. Excuse me. Y is equal to, what was it again? Negative 3x raised to 4. 3x raised to 4 plus 4 over cube root of x. 4 over cube root of x. Now, remembering one of the rules earlier, the sum and difference. Let's separate and differentiate them all by themselves. So we can combine them later. So negative 3x raised to 4 is pretty easy. 3x. Wait. 3. No. 3 times 4. X. 4 minus 1 would be negative 12x cubed. So this is negative 12x cubed. What about this? As we tried earlier, we can rewrite that. So 4x raised to negative 1/3. When rewriting, it's important to take note of the exponent inside the radical and the root of the radical. So this means x raised to 1 and third cube root, so x raised to 1/3, or in this case negative 1/3 since it's in the denominator. So 4 times 1, negative 1/3. Excuse me. Wait a second. Oh, 4 times negative 1/3. Oh, negative 4/3. I'm sorry. Negative 4/3. Negative 4/3 x. Negative 1/3 minus 1 would be negative 4/3 as well. So, excuse me, we can therefore rewrite this as negative 4/3 cube root of 4/3 cube root. Oh god, wait. Handwriting is so bad, so bad. 4/3 cube root of x raised to... No, it's not cube root. It's in fact fourth root. Fourth root of x cubed. Huh, I know. Fourth root of x cubed. Now knowing that, combining the two terms, so we have, okay, let's just erase this for a moment. Y prime be equal to negative 12x cubed minus, remember this is negative, 4/3, 4/3 fourth root of x cubed. There, pretty easy. And that about wraps it up, but I want to mention a few words about chain rule. Because chain rule is such an important concept that I'll introduce it here. Chain rule is a different, suppose y is equal to f of u. It's a differentiable function of u, and u is equal to g of x is a differentiable function of x. Then the composite function y is equal to f of g of x. It's a differentiable function of x whose derivative would be d of y over d of x is equal to d of y times d of u over x. Basically means that you would derive the outside function first, then multiply it to the derivative of the inner function. Sounds easy enough, right? But it will be much more complex in practice, and I want you to kind of just try to advance study on it. Just do some simple research about it, okay? So that about wraps it up. Thank you for listening to our mentoring session.